students, in this video I am going to explain conformational isomerism, some important points. First we look into the definition. It is a kind of stereoisomerism which arises due to free rotation CC single bond, free rotation of CC single bond. So because of free rotation, we are getting infinite number of conformers. But infinite number of conformers, you no need to focus. Only most important eclipsed, staggered and Gaussian. Gaussian form also called it as Q conformations. We look into this. So finally what I am giving the conclusion, CC single bond who is having alkanes. Whenever you are learning alkanes, we are learning conformational isomerism. Alkanes, geometrical isomerism. Why? Because restricted rotation. Okay. So now next one, infinite number of conformational isomers possible. So first I am going to draw the Newman projection formula for ethane molecule. Ethane means how many carbons, students? 2 carbons, right? See, this is ethane. This carbon, this is another carbon. First carbon having 3 hydrogens and the second carbon, this is also having 3 hydrogens. Okay. Now Newman projection formula. How we are going to draw Newman projection formula? I am giving the hint here, trick here. See what is this Newman projection formula? We are writing 2 representation. This is back carbon. Okay, somebody observing this one, somebody observing this ethane molecule towards the observer. Front carbon, this is back carbon. Front carbon we are representing like this, back carbon we are representing like this. The whole circle now this is carbon, but here it is carbon. Did you understand my point? See, here carbon, this is carbon, okay, and here the whole circle one we call it as carbon. Now I am going to draw the structure. Look into this. Ethane molecule. In ethane molecule we have totally 6 hydrogens, right? Front carbon have 3 hydrogens, back carbon have 3 hydrogens. Once again I am drawing here, I am writing here this CH, CH, CH. Due to CC free rotation, due to this free rotation we are getting the infinite number of conformers. Out of all, the most important one we are learning. See, I am writing back carbon first. Back carbon, it has 3 groups, atoms. That's it, hydrogen. Write down. Okay, I will write 1 second. This is back carbon. This is front carbon. Lines representation front carbon, circle representation is back carbon simply. Now see, front carbon has, this carbon has how many hydrogens? 1, 2, 3. You can write 1, 2, 3. Back carbon, this is back carbon. No? Back carbon also having 3 hydrogens. I am writing back carbon hydrogens with another color, better easily understand. This is hydrogen and this second hydrogen and third hydrogen. That's it. This is one form. This is one form. This form we call it as eclipsed form. This form we call it as eclipsed form. Similar groups, eclipsed form. Similar groups, same side, same here. Cis trans we have learned, no? Same like similar groups is very close. Similar groups close. Similar groups are close each other. Close each other. So then that form we call it as eclipsed form. Okay. Now next one. We'll write the another form. If you rotate this one, if you rotate to 60 degrees. If you rotate to 60 degrees, what happened? Look into the students. Circle. This is back carbon. Yes. Front carbon I was fixed. Front carbon I was fixed. That means Those hydrogens it is not changing, which is writing in white color. Front carbon hydrogens I am not changing. Now I am rotating back carbon. See, once I rotated 60 degrees, this hydrogen comes here. This hydrogen comes here. Okay. Now this hydrogen moves here, this side. Okay. This hydrogen moves here. That's it. This is another form. This form what we call it as staggered form. This form what we call it as staggered form. Like anti. Similar groups exactly opposite. See, look into this hydrogen, hydrogen, exactly opposite, exactly opposite, exactly opposite. Then what happened here? One important point. Staggered form is similar groups opposite each other. Opposite each other. Now, which is stability they are asking? This is less stable. Which is having less stable? Definitely it has more energy. Definitely it has more energy. Why it is less stable? Similar groups are very close, very close. Then what happened? Repulsions, torsional strains also more. Torsional strain generally we are calling. Here dihedral angle also 0. That is between these two angle 0, between these two angle 0, like this. So that angle we call it as dihedral angle. Dihedral angle theta here equal to 0. Here it is theta equal to 60 degrees. Okay. Repulsions more. Here students, similar groups are opposite, far away from each other. Then what happened here? More stable. More stable. If it has more stable, definitely it has less energy. Less energy, and repulsions are less. Repulsions are less. That's it students. Now if they are asking energy level diagram, see, suppose energy level diagram, potential energy diagram, which has more energy students? Which has more energy? More energy. Suppose they had given question like this. So this is what something. Okay. See which is having less energy, staggered form, which is having more energy, eclipsed form, and this is again eclipsed form, staggered form, eclipsed form, staggered form. Like this energy level diagram also we can write. Again 60 degrees. First so normal you can see 0 degrees eclipsed form. This is 60 degrees. Next if you rotate 120 degrees, 120 degrees. Next you can rotate 180 degrees, 200 degrees. Like that we are observing. So which is having more energy, less stable, which is having less energy, more stable. That's all. They'll ask questions like this. Now next one, Nbutane. We'll draw the structures. Nbutane. What is this Nbutane structure students? Nbutane. CH3, CH2, CH2, CH3. Now rotation between C2, C3 carbons. This is carbon 1, this is carbon 2, this is carbon 3, 4. Between 2 and 3 rotation I am observing. Between 2 and 3 rotation I am observing. Okay. Now try to write the structure. One is what students? One is back carbon, another one is front carbon. Suppose 2, 3. This is front carbon, this is back carbon. You can observe like this. Okay. Now yes, front carbon I am fixing. Front carbon I am fixing. One is methyl group, Me. Sometimes they will give Me also. Both are same. Me is nothing but methyl group. Now Me and 2 hydrogens are there. See this carbon having one methyl group, 2 hydrogens. 2 hydrogens I have written here. Now next one, this carbon having 2 hydrogens methyl group, no, that I am writing like this. Okay, I will use another color. This is what? CH3. Okay, and this is what students? Hydrogens. These 2 hydrogens you can write like this. See, so close each other. Similar groups are close each other. What is this form? We call it as eclipsed form. eclipsed form. Eclipsed form is less stable, right? Less stable means more energy. Now angle, if you rotate, this is 60 degrees. 60 degrees. See, front carbon fixed, CH3, and this hydrogen, okay, I'll write the white color only. I will write with white color, then easily you can understand. This is, okay, white color, that is nothing but front carbon. I am not disturbing front carbon as it is, I have written. Now if this is rotating 60 degrees means this guy will come here, CH3, and this guy will come here, right? Next, this hydrogen will move here. That's it. This is 60 degrees rotation. Now after that again 60 degrees. Here to here how much variation? 120 degrees. 120 degrees rotation means you will see. Again front carbon fixed. Front carbon fixed, CH3, H fixed. Back carbon. Now back carbon rotation here. This moves here. This moves here. Next, this guy moves here, hydrogen. This guy moves here. This is hydrogen, right? That's it. Now next one. Next again 60 degrees. Again 60 degrees. What you will get, students? Again 60 degrees. Totally you will get here 180 degrees, right? 180 degrees. Now again front carbon fixed. Will not disturb anything. CH3, H, right? Back carbon now rotating here up to here. This is. Next, this guy is coming here, right or not? This is coming here, and this guy hydrogen coming here. This is exactly opposite. See, similar groups exactly opposite. What is this form? We call it as staggered form. Staggered is more stable, less energy, right? Now next one, this is I am rotating again 240 degrees. Again front carbon is fixed, right? CH3, and this is what? H. This is what? H. That's it. Now can you tell what is the next one, students? Now what happened? This you can rotate. This will come here. This you can rotate. This will come here, and this you will rotate. This come here. That's it. Clear? Easy, very easy this one. Next one, 300 degrees. Next to 300 degrees. See again what happens? Front carbon fixed, CH3, H, right? Now look into the students, this one I am rotating, here it will come. Okay, now here rotating, comes here. Next here rotating, comes here. Next, if you rotate, what happened? Again first form you will get 360 degrees. If you rotate this molecule 360 degrees, you will get again first form. See, this front carbon is fixed, back carbon. If you rotate here, it will come. Hydrogen comes here. This hydrogen comes here. Same form, you will get it. Okay. So structure, this is 1. Take it as 1. This is take it as 2. Take it as 3. Take it as 4. And this is 5. That's it. Again, you are going to the back, first one. After 5 rotations, you will get the same thing. Okay, here they will ask question. If you want, you can write the 6th form. This one you can write first 1, 2, 3, 4, 5. This is 4, 5, 6. Okay, then 7th one it is going to the same thing. Okay, now I am writing, students, here first form and third form, and the next one, this is also 5th form. We call it as eclipsed form. Eclipsed forms. Next, 2, 4, 6. This is 2, this is 4, and this is 6. 2, 4, 6. We call it as staggered forms. In that again types are there, fully eclipsed and fully staggered, like that. We'll write this is, we call it as staggered forms. Staggered forms. Okay, and write one more point. First one is fully eclipsed. Fully eclipsed. Next, here one more point. What you will write? 3, 4, 3, 5. 3, 5. Partially eclipsed. Partially eclipsed. Next, here staggered. Staggered, what you will write here? Fourth one is, see, this is fully staggered. Fully staggered. Fully staggered is more stable. More stable. Next, 2, 6. 2 and 6. What is this? 2, 6 students are partially. 2, 6 are Roman numbers we can write, normal numbers also, no problem. 2, 6 are partially staggered. Partially staggered. That is only we call it as skew confirmation. That is only we'll call it as skew form or Gaussian form. Okay. Now, order of stability. The last questions here. Order of stability. So can you tell which is more stable, which is fully eclipsed? Fully eclipsed, that is fourth form. Fourth form is more stable. After that, second form and what is this? Sixth form. Second and sixth almost stable. Same stability. Fourth and sixth one. Fourth one and sixth one, this is more stable. After that, third one is equal to fifth one. Then last one is first one. Least stable is first one. First one is least stable. Energies means ulta, right or not? Ulta we are taking energies. Can you tell what is energy order, students? Energy order. Ulta we are taking. What is this? 1 greater than 3, 3 equal to 5, that is greater than 2 equal to 4. 2 equal to, one second, I'll write little down, it seems to be clumsy. Energy. So what is energy? 1 greater than, right, ulta, 3 equal to 5, that is greater than 2 equal to 6, that is greater than fourth one. That's all. This is energy order. Clear, students? Staggered eclipse form writing is very easy. And the most important note point I am writing. Generally, staggered conformations are more stable. Generally, staggered conformation. Generally, anti-form. Anti-form only we call it as staggered form. Both are C. Staggered form is more stable. Is more stable. Is more stable than Gaussian form. Than Gaussian form, right? But some special cases we have, students. In some special cases time what happens? Skew form is more stable. I'll write the points now. Generally anti-form, staggered form is more stable than Gaussian form. In between staggered and eclipsed, one more form will come, no? That form we call it as skew form or Gaussian form. But in molecules like, in molecules like 2-fluoroethanol, second position something, 2-fluoro, 2-hydroxy, like that it is there, 2-fluoroethanol. And next ethylene glycol, ethylene glycol. Next amino group also, some amino groups also there. Then it shows Gaussian form is more stable. I will show the point, students. This is one of the frequently asked question, 2-fluorophenol. I will draw structure, 2-fluoroethanol. 2-fluoroethanol. Okay, look into this. What is the structure? First write down 2-fluoroethanol. CH2OH. This is first carbon, second carbon, fluorine is there, 2-fluoroethanol. So write the structure. Now front carbon, back carbon. Again Newman projection formula we are writing. This is back carbon, front carbon, right? So now this is front carbon, fluorine, 2 hydrogens are there, right? This back carbon having 2 hydrogens, 1 OH group. This is Gaussian form, Gaussian form. I am writing, this is H, this is H, this is Gaussian form. This Gaussian form is more stable. Gaussian form is more stable than anti. Reason behind is here intramolecular hydrogen bonding. Any special bonding is there that is more stable. We have learnt in chemical bonding chapter also. Intramolecular hydrogen bonding. Hydrogen bonding. That is why it is more stable. Hope everybody clear this topic, students. Okay. Next, more confused topic in conformational isomerism, cyclohexane chair form. Chair form, axial and equatorial hydrogens are confusing, that I am giving. Generally, cyclohexane means, how we are writing, students? Cyclohexane, 6-member rings are more stable than 5-member ring. This is cyclohexane. Your carbon, 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 carbon. Each carbon has 2 hydrogens. Each carbon has 2 hydrogens. If it is ring structure, we are drawing like this. But why cyclohexane is more stable means it exists as a chair form. It exists as a chair form. See, I am showing here chair form. Chair form. Here I am writing another important point. 6 hydrogens are axial hydrogens. We are representing A. And 6 hydrogens, totally 12 hydrogens. 6 hydrogens are equatorial hydrogens. Equatorial hydrogens. Equatorial hydrogens. One second. 6 are axial hydrogens, 6 are equatorial hydrogens. Okay, and equatorial hydrogens we are representing letter E. Now writing chair form. See, parallel line first, upward, downward, again parallel line. Next, okay, one second, little confusion is there here. If you draw like this, little more easy. That's all. Draw like this. This is chair form. This is chair form. Okay, chair. You are sitting like this. Here, your head. Chair form. Okay. Now totally we have 6 hydrogen, students. I am drawing. See how easy this trick. See, we are writing up. This is first carbon. This is carbon 1. This is carbon 2. 3, 4, 5, 6. Clear? Carbon 1. Carbon 1 up. Carbon 1 up. You can write. Carbon 1 up. I am writing axial hydrogens first. Carbon 1 up. Carbon 2 down. 1 up, 1 down. 1 up, 1 down. This is down. Next, where is carbon 3? Carbon 3 is this. Up. Okay. Next, carbon 3 up. Next, carbon 4. Can you guess carbon 4? Yes, this is down. Carbon 4 down. Right. Now, next one. Where is carbon 5? Carbon 5 again up. Carbon 5 up. See, some of the students, they are confusing. Here I am drawing one more time. This is, one second. This is straightforwardly you can write. This is third carbon. Third carbon we are writing like this. Third carbon. Third up only. Okay. Next fifth carbon. So tell me fifth carbon. For up, down, up, down. Fifth carbon, what happens? Generally students tell me up only, right? This is up. This is up. Again you can write carbon 5 up. Carbon 5 up. Okay. Next carbon 6. Carbon 6 down. This is what students? Carbon 6 down. Yes. This is carbon 6. This is down. That's it. So one is, this is up. Right? Up. Right on. This is acyl hydrogen, acyl. This is also acyl. This is acyl. This is also, this is what down we have written. No? Down means acyl. Right? Now, next equatorial hydrogens. I am writing here equatorial, E. Equatorial. Carbon 1 opposite. Down you can write. This is down. Down means we are writing side. Side. This is equatorial. Carbon 2, what happened? Up. Means you can write like this. You can write like this. Okay. Now carbon 2 up. Next carbon 3. Carbon 3. You can see this is up you have written. No? This is down you can write. Carbon 3. So carbon 3 down. Next carbon 4. Carbon 4 up. This is down you have written. Up means side. Like this we are writing. This is up. Equatorial. Now next one carbon 5. Carbon 5. Carbon 5 here you have written up. Right. Now this is down like this. Parallel to this one. This is equatorial. Next this is what you can write. Next carbon 6. Carbon 6. What you have written here? Carbon 6. Down. Acyl. This is down. Carbon 6 here up. This is acyl. Acyl equatorial. Acyl equatorial. Like that we are drawing the structure. Sometimes they will ask questions here students. That's why I gave this one. So what they are asking question. So 2 acyl, 3 equatorial, 3 acyl. So what is this? 3 acyl, 2 equatorial, 3 acyl, 2 equatorial, dimethyl cyclohexane. Dimethyl cyclohexane. So can you tell what is the answer? Can you tell? See here only you can draw the answer, write the answer. What is the students? Yes. Second position, this is second position. Second position, what they are giving here? What they are giving here? Yes, second position, acyl. This is equatorial, this is acyl. Which I have to write? Where I have to write? So 3 acyl. Okay, one second, let me change this question. Yes, 2 acyl, 2 acyl, 3 equatorial. You can write anything, no problem. First I am writing 2 acyl, 3 equatorial. Write down 3 equatorial, 2 acyl. See, this is acyl, right? This is acyl. This is acyl here. This is acyl. Means here I have to write methyl group instead of hydrogen, methyl. Clear? Next, 3 equatorial. Where is the third carbon? Yes, this is third carbon. Third carbon, this is up one acyl, down one equatorial. That means this down you can write here methyl group. That's it. sometimes 2 acyl, 3 equatorial dimethyl cyclohexane, and 4 comma 5, 4 5 they will ask, 1 4 they will ask, anything they will ask. So finally, so this is the important question. That's the reason I had given students. So hope everybody clear what is cyclohexane, acyl and equatorial and before topics also. So prepare well for the exam, students. Please, many shortcuts I am releasing in our channel. So and short revisions also I am doing. Organic chemistry, the first year organic chemistry, almost the most important topics I have covered. Electronic effects and this isomerism, geometrical isomerism, structural isomerism, everything I have uploaded. Please go through the channel playlist. I have kept all the points. Go through that. So prepare well. Please give likes and subscribe our channel, students. Thank you. Thanks for watching.